Vanakkam. Welcome to this video on biomechanics. In the previous video, we were looking at the Zachorsky paper on enslaving effects in multi-finger force production. All right. So, we were looking at the experimental methods. Remember that the task involved placing different segments of the finger or the joints of the fingers, 4 fingers in 4 different loops and producing force with the instructed finger or finger combinations. Right. Either you place just with the distal phalanx or with the distal interphalangeal joint or with the proximal interphalangeal joint. Okay. And there were 15 different tasks, those that involved single fingers or 1 finger at a time, and those that involve 2 fingers at a time, those that involve 3 fingers at a time, and those that involved all the 4 fingers. Okay. And in each of these combinations or for each of these combinations, they performed the task with the finger either in the distal phalange or the DAP joint or the PAP joint. So, there will be 45 different experiments or 45 different possible combinations of trials that are possible. Okay. So, in this video we will be looking at the data that is collected and the method of analysis that they used. So, they asked the people to press as hard as possible with the instructed finger. At the same time, they measured all the forces of all the fingers. Okay. At the instant of the maximum force produced by the instructed finger, at the particular time when the maximum force is produced by the instructed finger, they measured all the finger forces. They also measured EMG to make sure that the participant is indeed following the instructions. If they are following the instructions, there will be no active force that is produced. If they are not producing active force with the non-instructed fingers, that means that they are following instructions. What is the instruction? The instruction is not to worry about the other non-instructed fingers. If they are producing active force with the non-instructed fingers or the slave fingers, if they are producing force, that means that they are not following instructions. So, the authors, they measured the EMG and they compared it with baseline. If the EMG for the non-instructed fingers is comparable to baseline, that means that people have followed the instruction. If they have actively produced force, then the EMG level will be higher than the baseline. This is the idea, this is the principle that was used to make sure that participants indeed follow instructions. Okay. And to analyze the data, they took a few things. First, they measured the magnitude or they computed the magnitude of the enslavement effect. Right. They found the force produced by a non-instructed finger or the uninvolved finger. Uninvolved means all the fingers are involved. What they are saying is that the non-instructed finger in a multi-finger task, they expressed it as the force produced by that finger in their single finger task. Okay. They compare the force produced by a given finger, by a given non-instructed finger in a multi-finger task and compare it with the force produced by that finger in single finger tasks. Then they also computed the longitudinal line with respect to which during maximum force production by all the fingers, a supination pronation moment equals 0. When I am producing more force with the ring and little fingers, the torque will be such that my hand is supinating. It's supinating. Okay. When I am producing more force with the index and middle fingers, the torque will be such that as if it is pronating. Right. This supination pronation torque will be equal to 0. What is the line about which, with respect to which this pronation supination torque is 0, right, depending on that location. So, they are interested in identifying that location x, where this is not capital I, this is where small I is IMRL, and XI is the individual fingers location. Okay. And they tried to compute the momentum of this moment, this pronation supination moment. They tried to compute the net momentum for that total moment with and without involving the slave fingers. If you involve the slave fingers, what is the momentum? If you do not involve the slave fingers, what is the momentum? This will give you an idea of the amount of force that is produced by the non-instructed fingers. Okay. This is the analysis that they did. Here as an example, what they found was that they plotted the force of the middle finger and the force of the index, middle ring and little fingers. They plotted this, and they found that there is an increase of force in both the slave fingers and the master finger. Okay. That is a concomitant increase or a parallel increase of master and slave finger forces, and it did not seem like there was any particular threshold after which enslavement force begins on this. So, there is no particular threshold for enslaving force production, is what they found. Also, one more thing that we define is the force deficit. What is this? What they found was that in multi-finger force tasks, force production tasks, the peak force produced by individual finger were smaller than the maximum force generated in the single finger tasks, MVC trials. That is, let us say I am producing individually, I am asking a participant to press as hard as possible with just the index finger. Let us say I am measuring 40 newtons, example. Okay. This is an example, so do not quote me on this. Let us say the index finger produces 40 Newton in a single finger task, I only task, only the index finger alone is performing, and this is what they are doing. Now, suppose I am asking two fingers to produce force, index and middle finger. Okay. This will be about 65 newtons for I and M. In this, this will be 65 newtons. In this, the index finger alone will produce 35 newtons. I contribution in IM task. In both the cases, the fingers were instructed to produce maximum. When index finger is working in tandem with the middle finger, why is it not able to achieve its maximum, individual finger maximum of 40 newtons? Earlier, it produced 40 newtons alone. When it is working with the middle finger, it is only producing 35 newton, middle finger is producing 30 newtons, for example. So, that means the peak forces of individual fingers were smaller, it reduces than their maximum force that they generated in single finger MVC task. So, their contribution to maximum force in a multi finger task is less than their own individual finger MVC. So, there is a reduction in their maximum when they are working with other fingers when compared with when they are working alone. This reduction is called as force deficit. This is called as force deficit. Okay. The other factor is called as enslaving. This is when the uninvolved fingers produced a substantial amount of force, when in the uninstructed, non-instructed fingers, when they produce a substantially large amount of force. Remember, our goal is to compare the amount of enslavement depending on the muscles that are involved, whether the muscle involved is only for the distal phalange or only for the DAP joint or only for the PAP joint, right. That is the goal. So, what was found was that in the three conditions between XDP, XDAP and XPAP, that is depending on where you place the fingers, whether you place it in the distal phalange, whether you place it in the dip joint and the pip joint, depending on that, if there is a difference depending on the experimental condition, that means the individual muscles do contribute to enslavement in a big way. That is the hypothesis, working hypothesis, is it not? But what they found was that there was no big difference between the three experimental conditions that were used. So, it is not like whether you are using the extrinsic muscle or whether you are using the intrinsic muscle has any big difference in the enslavement, and that is somewhat surprising, because extrinsic muscles send their tendons from the forearm, and we assume that some of the enslavement might be due to intertendinous force transmission and other such things that we discussed in the previous weeks, is it not? If that is the case, then you would expect those tasks that involve extrinsic muscles to have a greater amount of enslavement when compared with those tasks that only involve the intrinsic muscles, because the intrinsic muscles do not share tendons, right, but that is not what is happening. Then that means it is not merely the mechanics that plays a role, or mechanical effects are playing slightly lesser role when compared with neural factors, is the inference that we can get. Okay. They also confirmed that enslavement effect is non-additive, as was reported previously by Zachorsky and colleagues. Also, the occlusion effect was seen. I described what is occlusion effect, right. The occlusion effect was seen in major combinations of the 2 finger tasks and 3 finger tasks, okay. And like I said, that enslavement effect from 2 and 3 finger tasks were smaller than the enslavement effect from at least 1 finger. So, single finger enslavement effect is much greater than multi finger enslavement effects. Occlusion effect was confirmed, non-additivity was confirmed, and the enslavement effect from multiple fingers is smaller than the enslavement effect from at least 1 single finger, okay. Also, the moment arm of the resultant force was smaller when the enslaving force was taken into consideration. So, if you are considering the non-involved or the non-instructed fingers, the moment arm of the resultant force reduces, okay. So, that means that the enslavement effect, it appears to decrease the secondary moment or the pronation supination moment with respect to the longitudinal axis of the hand and the forearm. It seems like enslaving decreases as the distance between the involved finger and the non-involved finger increases. This is also an extension of the previous result. So, if you are far away from the involved or instructed finger, then that means that the enslavement effect is lower. If you are next, if you are neighbor of the instructed finger, then the enslavement effect is more. This might be because of spillover of commands sent to the flexor muscles. This is a hypothesis, right. The most important finding, the most important result from this study is that the enslavement effect between fingers did not vary depending on which muscle was involved in the task. If I was involving the extrinsic muscle, my hypothesis was that because the tendons are passing through or are moving close to each other, there might be some form of intertendinous force transmission or some form of mechanical coupling that might lead to enslavement, was the working hypothesis. If that was the case, if I do not use the extrinsic muscles in some tasks like we did in the experiment, in some tasks, for example the XPAP task, only the intrinsic muscles were used, right. The intrinsic muscles do not share a common tendon, each finger has its own intrinsic muscle. In that case, we expect to have less amount of enslavement when compared with those tasks that involve use of the extrinsic muscle. This is the expectation. So, expectation, reality. We will draw this expectation. If extrinsic muscles are used, enslavement is more. Enslavement is higher. Reality. Enslavement, or rather EE, enslavement effect, does not change depending on muscle involvement. Okay. In my opinion, this is the most important result from the study. What this implies, what is the inference, what is the meaning of this? The meaning of this is that enslavement is not merely a mechanical phenomenon as was hypothesis, that is hypothesis 1 for us, right, that it is shearing between the tendons that is causing the enslavement. It is this intertendinous force transmission that is causing this enslavement, this mechanical coupling that is causing this enslavement. These are the things that we said as the first hypothesis. If that is true, then in those tasks that only involve the intrinsic muscles, where there is no such intertendinous force transmission, there is no mechanical coupling, there is no shearing, in those cases enslavement must be less. But that is not what is happening. Enslavement does not change depending on which muscles are involved. That means that enslavement is not merely due to mechanical effects. It appears like enslavement is perhaps more of a central origin, is more of a central phenomenon, is happening somewhere at the neural level, or more of it can be explained by using neural factors than using mechanical factors. At least this is something that we can state. More of enslavement is explainable using neural factors than mechanical factors, right. So, enslavement effect exists among anatomically separate muscles such as the lumbricals, such as the intrinsic muscles like lumbricals, interossei. Of course, this study only involved flexion. Just saying, what are the intrinsic muscles? Thenar, hypothenar, lumbricals and interossei, right. So, force enslaving among remote muscles between two lumbricals, for example between the index finger and little finger in the XPAP task, right. If it is two lumbricals that are far away from each other, why are they enslaved? Maybe there is some form of neural interaction that is happening, okay. So, also one more reason is that we would of course assume that this multi-digit design of the extrinsic muscle, where one motor unit gives rise to multiple tendons, or one motor unit or fibers from one motor unit attaches to different tendons supplying different digits, may cause to lead to enslavement effect, okay. So, essentially either peripheral tendon connections and multi-digit extrinsic muscle could lead to enslavement effect, or plastic changes within the central nervous system leading to this secondary enslavement effect among intrinsic muscles. So, now we have some idea of the origin of enslavement effect. Now we can say as to why the musicians are able to unlearn enslavement, because if it is neural in origin, then learning and unlearning is a neural process. This is perhaps one of the reasons why the expert musicians are able to unlearn enslavement, are able to learn finger independence, not interdependence. Finger interdependence is what typical people have. Expert musicians have finger independence. So, they have unlearned enslavement, they have learned finger independence. Right. This is because perhaps enslavement is more of a neural process, perhaps something to think about. If you are interested in understanding more about how musicians use their fingers, I suggest you read the papers of this person, Japanese person, Shinichi Furuya is a Japanese researcher, extensive work on musicians and their finger performance. Anyone who wants to study musicians and their finger performance should do a thorough study of Shinichi Furuya's work before starting out any new work. There is also this classic studies by Ligense, I do not know how to pronounce this, Lense I suppose, who has also performed some excellent experiments involving enslavement. Of course, there are the other standard studies by Kilbreth and Gandavia. Then the study on kinematic enslavement by Ross and Schieber, which we will discuss in a future class. Okay. So, in this video we looked at what is enslavement, and we looked at the background to the research study on enslavement. We discussed the 1998 paper and its major results on enslavement, and then we discussed the first research paper, which is the paper by Zachorsky, Zhongming Li and Latache, published in the year 2000. We discussed the background and introduction for that, we discussed the methods in good detail, we discussed the major results, and we also looked at what these results mean or the inference from these studies. The major takeaway from this is that enslavement is perhaps a more of a neural factor than a mechanics based factor. So, again another example of how structure and function are related. Throughout this course, this is the theme that we are interested in, structure function relationships. Okay. Well, with this we come to the end of this video. Thank you very much for your attention.